Say, get it out now.
Here we go. Just say what you want. All right. Okay. So a transformation is a change that's applied to a basic function. And there's several changes you can make. You can make those that are rigid, meaning you do horizontal or vertical shifts. And that'd be like up, down, right, left. Those are called rigid transformations because you're not changing the shape of the graph. You're just moving it left, right, or up, down. That's all that's happening for rigid transformations. Non-rigid is when you do change the shape and size. So those would be stretches. Yeah, those would be like stretches when you do a non-rigid transformation.
What does that mean? You just don't change it all?
No, the shape changes. So the graph gets stretched. Not
it doesn't shape it change, but it just moves.
Right. So in this case, if it's non-rigid, it might
extend on one side.
It might stretch or shrink. Okay. So anyway, let's talk about the rigid transformations first. Shrink or shrink. All right, so let's look at this graph here. H, just so you know, in case you guys forgot, H is the horizontal shift, and K is the vertical shift. Very simple. God bless you. So H is a horizontal shift, K is a vertical shift. So Y equals X squared. I'm going to do 3 graphs here. I'm going to do this in green. I'll do this in light blue. I'll do this in pink. God bless you. May need to dust the classroom. Okay.
Well, because I had a big breakfast and I think it's satiation where if I eat a lot, my stomach expands and I sneeze.
Okay. I like that. Thank you. All right. Really? Okay. All right. Okay, Y equals X squared. Is that right? Now, that's pretty simple. The first one I just did. What about X squared plus 3? Yeah. Do 3 up. Exactly. So in this case, you're going to go 3 up. I already have a question. No. Oh, okay, I thought you were raising your hand. So you just do this. That's Y equals X squared plus 3. And then what do you think I do for the pink one? It's, yep. What about, I'm sorry? I just plugged in numbers. I plugged in 1 and 2, got the outputs. What are you asking? Oh, okay. All right. I wasn't sure where you're.
When it's X squared, I remember I'm forgetting on it, but there's specific numbers you always plug in, right?
I do 0, 1, 2, and then the negative counterparts. So.
Is that last year?
Yeah. It's like shebang numbers.
Oh yeah. Who's your teacher last year?
Was it Mr. Prue?
Yeah.
Yeah, he moved to Tennessee.
Oh yeah.
He moved to Tennessee.
Yeah, it's sadly he got priced out of the area. Just the housing was just really. He has 4 kids.
Yeah.
And then I don't think his wife works.
Yeah, right.
And then his mother also moved in.
Yeah.
So they had 7 people living in a 3-bedroom house. So it was
a lot.
Yeah, and I've heard a lot of people actually moving to Nashville. Like it seems like that's you could buy a much bigger house and it's got a decent economy there. So yeah. Anyway. I've never been. I'd love to go. Yeah. And what? Sorry. No, okay. So the conclusion is that K
is dy.
Causes the graph Move up or down. Here we go. So each of these are K.
So K is a number you're adding to the outside of the function or subtract. Subtract vectors up.
What's the, when is it shifting the X?
That's the next one.
That's the number that's.
No, that's it. That's gonna be H. So in summary, K here was 0. K here was 3. And K here is -1. I probably should have mentioned that first. And H was 0 for all 3 of these, right?
Because there's no H value, right? You're not subtracting anything inside the square symbol, but you are adding subtracting to the outside of the square symbol. Like PEMDAS, right? You square and then adding subtracting. Okay.
Let's keep moving, guys. Can I move the screen? Good. Okay, great. All right. Next up. Okay, so JP, you're asking about what happens here, right? So in this case, now K is 0. But H changes.
Why is it any different than the first one?
Because now you're doing it on the inside. So here H is going to be 0.
Yeah.
H is going to be 2. And H is going to be -3. So I graph the first one, and again, let me color code. Green, light blue, and we'll do red. So if I graph y equals x squared, that's easy. We know that already, right? There we go. Now, x minus 2, H is 2, so you're going to shift which direction. So it's a little counterintuitive, because if you see the -2, people think left. It's actually right. So you shift to right. So it does this. And you go to Desmos or your graphing calculator, you'll see that for sure. For the purple, sorry, for the red,
Oh, tonight is going up.
it looks like that.
Yeah, because there's no K value. You're not going up or down. We're just going left or right. Because I only impacted extra. So yeah, if you plug in, if you plug in 1 minus 2, you'd have 1, right? If you plug in 3, you'd also get 2. Exactly. And guys, this is very important because so far can't emphasize this anymore. You have to think about order of operations. PEMDAS. That's why we did PEMDAS on day 1, right? Actually, I don't think we did. You should. But most classes, order of operations, right? Because what's the first thing you're going to see is the x minus 2, right? First thing x sees is that -2. And that's causing the horizontal change. Then it squares afterwards, and then if you have it on the outside, that's done less. So the first thing it sees is that x minus 2. So you're subtracting x by 2. In actuality, you're adding 2 to the x coordinates for the parent function, because it's in order to counteract that change, you have to put 2 in to get 0 for y. Or here, what I have to plug in for x to get 0 for y? -3, right? That's why it's counterintuitive, because in order to counteract that plus, you have to do -3 to get the same output. But for up above, the plus or minus was outside the square. So you would square first, and then you would add or subtract, right? For what we did in the previous example. So that's why the graph moved up or down after to change y, not x. So the conclusion here is that H changes the graph horizontally. Again, should we all review? The graph horizontally. And this is true for any function. Trig, this stuff, square root functions, log functions, whatever, right? Cubes, bunch of stuff. All right. So now let's kind of come up with some generalizations, and then we'll talk about stretches. So these are all called, so everything we did so far were called translations. And simply what's happening is that you're
moving the graph up or down or whatever. So I'll put this as a text box, it'll be much easier. So when you see this here, that results in a translation of H units to the right. This would be H units to the left. This would be K units up. And this would be K units down. That's it. So if you see,
So generally speaking, right? If you see something directly impacting X, X is horizontal coordinate. Go left or right. You see something on the outside, because X is Y, go up or down. That's all. But it's counterintuitive with the X. Minus H, you have to, if it's minus, you gotta go to the right, because you have to plug in H for X, to counteract that change. Or negative H here. These we'll see are a little more intuitive, right? If you have a plus K, we have to go up or down. Because f of X is Y, or you have remember Y is f of X. But if you add it to the outside or subtracting,
you just do what seems intuitive. Okay, so that's what's happening in general terms. Okay, questions? No? All right, let's talk about these changes and then summarize that, and then we'll reflect, and then we'll kind of combine all this stuff. All right. So let's talk about these here. Vertical and horizontal stretches and shrinks. So again, I'll do this in red. No, again, I'm mixing my colors, whatever, it's all good. And we'll do bright green. Okay, so y equals x squared, again, sound like a broken record, we know what happens there, right? You have points here, 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 here. Now, what do you think happens for the blue curve? The 2. What do you think that 2 is going to do? Yeah, all y coordinates get multiplied by 2. So guess what? I'm going to do this. It's kind of like slope in a way, not exactly, but kind of is like slope. So that gets stretched. So that gets vertically stretched by a factor of 2. Because you multiply all the y values by 2. What do you think is going to happen to the green now? Yes, good. Look, just walked right in. You already knew what's going on. All y coordinates get divided by 2. So in this case, we say it's vertically shrunk.
Is that the same as like having an exponent of 2.5? Or no?
No, that's an exponential for that. That's much
Yeah,
different.
That would get rapidly smaller.
That's we'll cover that in a later unit. Vertically shrunk by a factor of 2. So in this case, if I plug in 1, I get 1/2. If I plug in 2, I think I get 2, and so forth. So
that got multiplied by 2, X squared got multiplied by 2, X squared got divided by 2. Or multiplied by half, same thing. But you say it's a shrink. If the coordinate, sorry, if
it's an a value. So these are all a values. So here a is 1, here a is 2, here a is 1/2. H and K were both 0. So we didn't move the graph horizontally, vertically, we just switched a. A was 2 or 1/2. And so that's what happens there. So the conclusion is that A
Doesn't A shift on the vertical line?
Nope. Because origin, the vertex was at the origin the whole time. Every single time my vertex was at 0, 0. That didn't move.
Yeah.
The only thing that changed was whether I stretched it or smushed it. That's all that changed. And that's what A does. If A is bigger than 1, we stretch. So that's another thing we should mention too. If A is larger than 1, stretch. Don't worry, we're gonna review again.
Checking in like it gets wider
Vertically stretched, that means you make it get skinnier.
or, oh, but, oh, wait.
If that helps, it gets skinnier. If A is less than 1, well, between 0 and 1. If A is, geez, that's really messy to me.
Hey, girl. What are you saying?
It was like a big girl loving her parents.
Yeah.
Okay.
Look, Kurt.
Yeah.
That's what he said. Yeah, I thought he was gonna introduce himself.
Oh, yes.
Oh no.
No, they didn't.
No, the rapper poets.
Hey, girl,
You and then me and her and Iris and me and Iris and this one.
Wait, it was right
Yeah,
after
you just
the
like-
one
you
that
start
was
like-
called the.
Yeah.
Wait, which
And you start rapping and we start dying up right in front of him. So.
Oh really?
I started
like,
laughing.
he also told us he's sagging.
I started.
Wait, he
laughing.
what? Sorry.
He was sagging.
Oh, I didn't notice that.
His
Okay.
jeans were, like, sagging like 6
Okay.
inches.
I thought he had some funny comments too. He was like, thank you to all the grandmas who ate and drank water.
Oh, I didn't catch that either.
A young man in the crowd.
Yeah, he was like, moms probably have more courage than all the young men here.
No, and then he repeated, he was like, oh, you young man. I was
But
like,
then he followed up with like, this is a white supremacist. Oh my god. The audience is like, you're not the right audience.
and then he's like, his time's up, and then he asked to do one more song. He like picked his microphone, he was like, can I do one more? And they were like, Ashley microphone, like, sure.
You guys are very observant. I was sitting far back, but anyway.
He was gonna smoke it and I started laughing because like not at him. I was just trying to laugh.
No, it's it's the act. Yeah.
Because it was also right up to the moment itself, like I had to laugh. I was just like dying laughing. Leave.
I can see
I had to run out. And, like,
Well, I know phone is definitely.
What was that?
I have my phone, I'm like,
Yeah, good.
we gotta do no phone.
Okay, guys, really quickly, I know we got off track a little bit.
So again.
I'm so
A,
glad.
five plays,
It's such a
let's
good
go a little more
answer.
cover, how much we have left time to do it, and you guys can get this. So A, the number in front, A is the number in front, that vertical stretching of shrinks. If A is bigger than 1, it gets skinnier because you're doing this, right? If A is between 0 and 1, it smushes, it goes sort of like this. Yeah, that's what happens.
I kind of beat that to death, so let's go to example 4. Now, in this case, I'll call this letter C. So y equals cx squared. So here C is 1, here C is 2, and here C is 1/2. And again, H and K are still both 0. And A is 1 for all these. So this is a little different. This is going to be called a horizontal. I'll tell you the conclusion right now, just so you know. C horizontally shrinks or stretches. It's definitely counterintuitive. You'll see why. That shrinks or stretches. So let me graph the first one. Obviously, I know that's going to be. I'll do different colors again. Red, light blue, and we'll do black. So you have this right here, right? Y equals x squared. Now we already did this. I know that's actually y equals 4x squared. So it actually is going to look like this. And that the other one's going to be y equals 1/4 x squared. It's not that much, it's just the way we'll describe it will be a little different. You'll see in a sec. If I plug in 2 Yeah, I get this. So that's y equals parentheses 1/2 x squared. And the blue again was y equals parentheses 2x squared. So here's what happens. There are no negatives at all. Where are you getting the negatives from? No, that's just the color. That's my color scheme.
Then what's that? So y equals what?
Here, I'll just do that. So that's confusing you. Y equals x squared.
Y equals negative 1.
Y equals x squared.
No, the blue.
Y equals 2x squared, parentheses 2x squared. Okay, Charlotte, we need to back up a little bit. All right, well, I squared this, right? So that's 4x squared. Sorry if I glossed over that. I did say it though. But I say a lot of things really fast. And that's y equals 1/4 x squared. So what happens is this, for the blue, you're gonna say it gets horizontally shrunk. By a factor of 2. Because you're actually bringing it in. You're shrinking it horizontally. And this one is going to be the black. That's going to be horizontally stretched. I know it seems counterintuitive to see a 1/2. But you say that's horizontally stretched. So what I'm doing is actually, I don't know how this was taught in Algebra 2, because I do teach in Algebra 2 also, but I don't teach it to this depth. I'm definitely teaching it at a greater depth today. Because we want to do this the right way before you guys move on to calculus. Horizontal stretch. I think we kind of do it lighter in Algebra 2 because it's the first time you're seeing it. But we're going deeper here today. So you would say this is horizontally stretched.
I know it's a bit counterintuitive, but clearly it is stretched. The black is stretched compared to the red.
Where the blue is horizontally compressed or shrunk. Right, the black is going to be horizontally, excuse me, horizontally stretched by a factor of 2. It's kind of similar to what JP is saying. It's kind of similar to what we did in the previous ones, but it's the description. You're using horizontal instead of vertical, so you have to describe it a little differently.
It still gets skinnier and fatter.
Yeah, it does. Yes, absolutely. So this case it got fatter, and the blue got skinnier.
So the black one got fatter?
Black one got fatter. Even though the number is smaller, it did get fatter. Or wider. Okay. So let's generalize this. Here's a generalization that happens. If C is bigger than 1, that is a vertical stretch by a factor of C. If C is between 0 and 1, come on. Then we say it's vertically shrunk. And you're going to say 1 over C, just so you know. You're going to flip it over. So for example, oh, it's not wet. Oh goodness, come on. Hold on. That was what I put in the attendance. Sorry. Okay, let me copy and paste. There we go. Select text. Much better. Okay. So here you're going to say this. If C is bigger than 1, that's going to be horizontally shrunk. And C that'll be horizontally stretched. And again, whenever you do the whenever C is less than 1, the factor you'd say would be 1 over c. So for example, if that were like 1/2, f of 1/2 x, we do 1 over 1/2, that becomes 2. Or here, if you have 1/2 times f of x, if you do 1 over 1/2, that also would be 2. So you say it's shrunk by a factor of 1 over c. Okay, let's talk about reflections and then wrap it up. Okay, this should be pretty easy. Root x is this. Again, this is my color scheme, just so you know, that's my color scheme. This right here, you're going to reflect about the x-axis.
No.
So it's going to look like this. Negative root x. And I'll do this in light blue. You can reflect about the y-axis when it's on the inside. So it's going to look like this.
Is the negative literally just the same thing, just going opposite way?
Totally. Yep. Now, why is the blue going to the left?
It's going to the left because you can't plug in positive x, right? Can I plug in 4 into this last equation? No. Well, root negative 4 is plus or minus 2i, right? It's imaginary. So I got to put in negative x values to make this legit, make this real, right? I got to put in negative x values. That's why it's going to the left. It's going down because I got a negative in front. It's going down.
So wait, sorry, can you read?
Sure.
The negative.
So the negative on the inside,
Yeah, so you can't, so think about the domain, right? Like for root x, I can only plug in positive x values here. And of course, when I square it, it becomes positive, like root 4 is 2, root minus 3. Here, same thing, I'm going to plug in only positive x for x for my domain. But my out of my range is going to be negative.
Yeah.
Because of negative output. That's why it flips over. Yeah. And actually, I'm glad you're asking this. That's actually, I'm going to teach you better than next period to be asking this question. Because you got to think numerically what's happening, right? I think that's for us. Like here, numerically, I can't plug in positive x. Like I'm plugging in 2 and I'm plug 4 on the top. So I got to plug in negative numbers, and that's why it's 3. So guys, look, what I especially just gave Charlotte was really, I think, beneficial because you have to think numerically what's happening. Only plug in negative values here, the last equation. That's what this is. For this one, you plug in positive values, but the output's negative. That's what's going on. And of course, that's just the parent. Plug in positive values for x, the output's positive also.
okay. So that's reflections. So the conclusion is that if A is negative, reflect about x-axis, and next one that's a C. Sorry, that's an A. Reflect about and generally speaking, we're going to think of like this. In general terms, A times F of C times X. So we're going to think like that in general terms. A is the number on the outside that's multiplied C's number on the inside will be multiplied X. So if reflecting across x-axis results in negative F of X, resulting across the y-axis results in F of negative X. So the x-axis results in the point x comma negative y, and there results in negative x comma y. So now let's put it all together. Let me do the parent function in black. This is absolute value. You guys should know this. So it's y equals that. Let's do this one in red. Here's what I'm going to ask you guys to do. Identify A, H, and K. A is -1. What's K? +2.
Oh, yeah, might be.
And K is 3. So what I'm going to do is I'm going to shift
Up 3 over 2.
Yeah, I'm going to shift to left. Sorry, to right. Reflect. Let me just do a text box. That'll be easier. And I'm going to do this in the proper order too. Shift. Wow, that was a Freudian slip there. Shift to right. Reflect about x-axis. And shift 3 up. Now the order matters, by the way, guys.
The way you say this, I don't know if you're out to did it. The order does matter. PEMDAS, right? If I plug a number for x, instead of plugging like a 5 here, what's the first thing that 5 can see? If you're to compute this, the -2, because like the absolute like it's like for instance like PEMDAS, right? Well, the -2 causes the horizontal shift. So you state that first. After you do the absolute value, what's the next thing you do? You add the 3 and multiply by -1. Multiply is the n and PEMDAS. What does that do? That negative reflects about the x-axis. Lastly, you add the 3. What does that +3 do? It shifts the graph vertically up.
I am going to be a stickler about that because in order to do calculus correctly, you have to know your transformations in the right order. I cannot emphasize that anymore. That's when I was taught calculus for 2 decades. You have to know your shifts in the right order. Calculus will be a nightmare if you don't. You got to know in the right order. Shift to right, reflect, then shift through. If you shift before reflecting, your graph is going to be off. I'm going to just say that right now. You have to do things in the right order. So if I shift to right, clearly I'm right here. But then I gotta go. Then I gotta reflect. So I'm going to be pointing down, and then I go 3 down. So 3 up. Sorry. So the other points do the same thing. 1, 1. I gotta go 2 right, reflect, and then go 3 up. Or -1. I gotta go 2 right, reflect, 3 up. And that's y equals negative absolute of x minus 2 plus 3. Okay. So what happened to that point on the transformation graph? So again, what happened is all this right here. That's what happened. And let me order matters. Order matters. So okie dokie. Lastly, these here. Again, this is last, I promise we're done after this. It's just last page. So in this case, you're going to shift 3 right, then shift 7 up. One. There we go. This one, you can reflect about the y-axis, then shift 1 down. This is negative out in front. Sorry, this is negative inside. If it was out front, you go about the x-axis. So think of it this way: it's a horizontal flip.
Oh, shoot.
It's a horizontal flip. If it's negative outside, it's this.
So it's going like this. To the left.
Yes, totally. It's pointing left and then one down. Yes. Actually, you can think of it like that. Yeah, that's a good way of thinking about it. Oh, come on. There we go. There we go. All right. All right. Next up. So you're going to horizontally shrink by a factor of 3, then shift 3 up. Because you have a 3 being multiplied, it's a horizontal, and because it's greater than 1, you say it's a shrink. This one here, you're gonna do, what's up?
The factor is in front of the X or not only?
It's front of the X. Yeah, actually, I'm glad you brought that up. There's 2 3s, right? I can see. But the plus 3 is always, anything you plus outside is always a vertical shift. And that's gonna be that one right there. Thank you for clarifying that. All right, and then this one here, come on. Vertically shrink. Ah, come on, what's going on? All right. Vertically shrink by a factor of 4, then actually, hold on a sec. You're gonna shift to right, then vertically shrink by a factor of 4. And this last one here, we'll just skip it for now. Let's not do it. Okay. Yeah. All right. So anyway, it's 9:30. Let me stop the video.
You go over to the